ओके जी, कैन यू हेयर मी? आवाज आ रही है जी?
Yes, sir.
ओके जी. So we were in the beginning of the center tap transformer, center tapped rectifier circuit. So in that, what we have basically the primary and the secondary winding, and the turn ratio are 1:2. So this means the whatever the primary, the secondary is going to be the double of the primary. So whenever we are applying the positive half cycle, so in the secondary we have the positive half cycle, and due to this positive half cycle, the diode D1 will behave as the forward bias, and diode D2 will be behaving as the reverse bias. And due to that, what happens that the current will be flowing from D1 to the resistor R. And this means the output will be across the resistor R in plus and negative direction, right? Now, when the negative cycle comes, this means the diode D1 will be behaving as reverse bias, and diode D2 will be behaving as forward bias. And due to that, the negative half cycle, this means the negative half cycle, this side is going to be, this side is going to be negative, this side is positive. Again, this side is going to be negative, this side is going to be positive. So due to this, the diode D2 will be forward bias and diode D1 will be reverse bias. And due to this, the current will be flowing from D2 like this and in the same direction through resistor R when the diode D1 was forward bias. So due to that, the output which we are going to get, it is due to D1, we are going to have a positive half cycle, and due to D2, we are going to have positive half cycle. And again, when the next cycle comes, then again D1 is forward bias, and then when the negative half cycle comes, D2 is forward bias. So the output is going to be something like this. Are you with me?
Yes, sir.
Okay, ji. So due to this, what is happening over here, that we can see that the output is something like this. Okay, ji. And the point is that both the bridge rectifier circuit and the center tap rectifier circuit, they provide the full wave rectification, means it provides the rectification in the positive half cycle as well as it provides the rectification in the negative half cycle. And due to this, the average value is the same as which we have shown it in case of the bridge rectifier circuit. And what about the peak inverse value? So the case of peak inverse value is that whenever we have the secondary winding, over here we have the resistance, and over here we say that let's suppose diode D1 is behaving as an open switch, right? So at this specific time, whatever the maximum value we are over here is Vm. Again, the maximum value which is across R is Vm. So if we apply KVL over here, so the peak inverse value across the diode D1 will be equal to the drop across the resistor plus the potential across the secondary winding, right? So due to that, when both are being added, So this means the peak inverse value in case of center tap should be greater or equal to 2 Vm. Are you with me?
Yes, sir.
बात समझ में आ रही है जी?
Yes, sir.
Okay. So what we have seen up till now that in case of the center tap rectifier circuit, we need to have a greater PIV or PRV value for the diodes as compared to that of the bridge rectifier circuit. Okay, so what we are getting up till now is basically unidirectional output. But what we want to have something uh, quite uh, uh, quite close to DC value. So how we can get that? So if we see that if we go back to the starting point from where we have started, we started from the half-wave rectifier circuit, right? And in the half-wave rectifier circuit, we had a diode and a resistor. Now, if we install a capacitor in parallel to that of a resistor, how this circuit will behave? Let's see. If we say we have the AC source, we have the diode. Now with the diode, what we do, we install a capacitor as well as a resistor in parallel to it. How this circuit is going to behave? Now we have C and R. Anyone? G. What will happen now? Any idea? Okay, let's see what will happen. Again, we say, let's suppose consider the diode as an ideal diode. Now, if we consider the diode as an ideal diode, so what will happen that whenever we are having the positive half cycle, VI, whenever we have the positive half cycle, so consider the diode as an ideal diode, what will happen that once the value is increasing, at the same time, what is happening that the capacitor is also charging with the value. So as the value is rising, the capacitor is charging in this direction. This means this end is charging with the positive charge, right? So the capacitor is charging as long as the value is rising, right? As long as the value is increasing, of the input value is increasing, the capacitor is charging. Till the time the input voltage reaches to its maximum value, which is Vm, right? Because the charging is done through the diode, right? And once we say that the diode is behaving as an ideal diode, so this means the resistance which is being offered by the diode or the time constant in charging of the diode is very, very small, right? So because the capacitor is charging through the diode, so this means the capacitor is going to be charging instantaneously as along the rise of the input voltage. Once the value of the input voltage reaches to its maximum value, the capacitor will be charged to its maximum value, which is Vm. Are you with me? बात समझ में आ रही है?
Yes, sir.
ठीक है जी. So as long as the input voltage is rising to the maximum value, the capacitor will be charged to its maximum value. Now, the input value after the maximum value, it will be reducing from its maximum value, right? So once it is trying to reduce from its maximum value, so this means what is happening, that this point, that this side of the diode is now having value equal to Vm, but the other side of the diode, which is the P side, it is now having less than value equal to Vm. Why? Because the input value is now decreasing from its Vm value. Are you with me? Yes, sir. बात समझ में आ रही है? Are you understanding what I am talking about? Okay, take a look again. What I am saying, that if we consider the diode as an ideal diode, so when we consider the diode as an ideal diode, so this means the diode will be behaving as a closed switch. When it is behaving as a closed switch, so this means whenever the input voltage starts rising from zero and it starts rising, so this means the capacitor will be charging instantaneously, because the capacitor is charging through the diode, which is offering very negligible resistance because it is behaving as closed switch. Closed switch means it is having negligible resistance. Due to this, the capacitor is charging instantaneously along the rise of the voltage. Once the value of the input voltage reaches Vm, so this means the capacitor is also charged to the value equal to Vm. Now, when the input starts to decrease from the value Vm, because once it reaches over here, now the input is starting to decrease from Vm, right? So when the input starting to decrease from Vm, so this means this side of the diode is having value less than equal to Vm, right? Are you with me? So this
Yes, sir.
means this side is now more positive as compared to this side. And once this is happening, so this means the diode is no more forward bias, but it will become an open switch at this very point. Okay, ji? Are you getting it? And due to that very reason, now this diode is behaving as an open switch. So this means the capacitor cannot actually discharge through here. So the only path which is left for the capacitor to discharge is from the resistance R, which is in parallel, and across this we are actually getting the output from it. So if you see the output over here, will be something like this. Output will be till Vm, it will be like this. And previously we had the output something like this, then this, and then we had something like this, right? So this was the output without the capacitor. Now with the capacitor, what is happening? We have, this is at the output. Now the output, because as the capacitor plays its role, so the output is not going to go along this path, which was the previous path, but the output will try to maintain over here, because the capacitor can only discharge through the value R. If the value of R is very, very high, so the output will be something close to the peak value. But if the value of R is small, so the capacitor can discharge quickly. So depending upon the value of R, the output slope will be dependent upon that, right? So if the value of R is very high, so the capacitor can maintain its charge to the value equal to Vm. If the value of R is in the middle, the slope will be something like this. If the value of R is very, very small, the slope will be something like this. ठीक है जी, बात समझ में आ रही है? Are you with me?
Yes, sir.
Question?
No, sir.
Anyone else having any question? This is very important point, therefore I am discussing it all.
No, sir.
Question तो नहीं है जी?
No, sir.
Okay, thank you. So depending upon the value of R, the output is dependent upon that. So if the value of R is very high, so the slope will be something very close to R. So again, when the negative cycle comes, the output remains over here like this. When again the positive cycle comes, so by the time the input starts to rise, if you see, the input starts to rise over here, and by the time this value, which is across the capacitor, becomes equal to the value of input over here, right? If this is the point where the value of capacitor is there, so at the point where the input becomes equal to the value of capacitor, so then the capacitor will actually charge during this portion, right? So during this time, the capacitor will charge only this point. And again, when the input start decreasing, capacitor will have output like this. So if you see, the output is dependent upon now the filter. The filter over here is basically, the capacitor is behaving as a filter, which is actually filtering out the unidirectional signal, which is close to DC, or this is also called ripple output, because the output, if you see, it will be something like this. It is something like this. So this output is called normally ripple out or ripple voltage, or it is also called ripple voltage. Okay, ji? So the same thing happens if we have the full wave rectifier circuit, because if you see, in case of full wave rectifier circuits, we have peak something which are very close. So this means the capacitor will be charging to this point, and small drop over here, then charging over here, then small drop over here, then charging over here, then small drop, and in this way the output will be actually having small ripples. But in case of half-wave rectifier circuit, we have actually big ripples over here, right? So depending upon that, we can actually have the outputs that can be close to the DC value. And if we have the time constant is basically the C into R is basically called the time constant. So if the value of R is very high and the capacitor can store a lot of charge, so if the CR value is high, so this means if the time constant is high, so this means the capacitor can maintain the charge at the peak value. And when it can maintain the charge at the peak value, so this is called the conversion of the AC signal into DC signal, right? So that is basically the purpose of the rectifier. And when the filter is being connected with the rectifier, we actually get an output which is close to DC, depending upon the time constant or depending upon the value of the capacitor and that of the resistor. Okay, so this is how the things are. What I will say that kindly go through the examples which are given in the book, and the examples are 2.1 to 2.10, and then the example 2.16, 2.17, okay. So go through these examples, 2.16 and 2.17, as well as 2.1 to 2.9, right? So they are actually going to give you the fair idea of what we have discussed for today. Any question? That's it from my side today.
सर ये लाइन जो है ये स्ट्रेट कब होगी?
जी यही तो मैं आपको बता रहा था, ये अगर आपका टाइम कांस्टेंट बहुत बड़ा हो जाएगा, टाइम कांस्टेंट जब बहुत बड़ा हो जाएगा, इसका मतलब है कि रेजिस्टर जो है आपको चार्ज को डिस्चार्ज, कैपेसिटर को डिस्चार्ज नहीं करने दे, राइट? सो जब कैपेसिटर डिस्चार्ज नहीं होगा, सो दिस मींस द चार्ज विल रिमेन देयर or the capacitor will be charged till the maximum value, and once it is being charged till the maximum value, so this means the output will stay at VM, right? ठीक है जी, बात समझ में आ रही है?
Yes sir.
Okay जी, that's it from my side. Okay, thank you.
Thank you sir.
Thank you.